Okay, so I have just a few introduction slides. So I work for a company called the Deltares. You can see all the parties that we work with in this project, which is called C-Scale, and this is about use cases for applied sciences, and we are trying to deploy this on European infrastructure. And of course, a part of openEO is of course the infrastructure that they provide and all these backends that will do the heavy lifting for the Earth observation workflows. And in this case, of course, as Deltares, we have a lot of experts and scientists on it's called enabling Delta life. So in this case, we have a lot of use cases for Earth observation on, for example, predicting droughts or seeing the extent of flooding, monitoring water resources. So we are quite interested in what openEO has to offer. And in this project, we have an app which is called Aquamonitor, and we wanted to see what we can do to make this also work on using openEO. And in this workshop, I will walk you through a notebook that implements the algorithm, and to give an idea to you what you can, for example, do with openEO and also get some hands-on experience with it. So this will be like a twofold goal for today. But at the end, I hope that you can get started with openEO and as well as understand a little bit what you can use it for. Because I know there are some experienced users that already work with EO data, and there's some people here in the call who were just participating and looking a bit newer. And I think this will be interesting for both of you. So I'm presenting this together with Arjen Haag. Arjen is in the chat, and he has been also. I'm not don't want to butcher your CV, but you've been working with this for quite a few years already, using EO data, and now also recently started with openEO. So what is Aquamonitor? Aquamonitor is an app that has been looking for over satellite data from different missions for over the last satellite data from 35 years, since I think 1985, and checking to see whether certain areas, so in this case you see a whole lot of highlighted points on the map, and where you see a green highlight, it means that surface water has turned to land, and the blue area means where surface so land has turned to water. So we are monitoring land to water and so surface to water and water to surface changes for over the last 35 years. And this is, of course, a huge operation because we are using many different sources and all images for over the last 35 years. So as you can probably imagine, this is not possible on just your own computer or on two computers. This really needs a massive scale infrastructure, and all this logic to manipulate the data over multiple machines. This is all possible using openEO. But so here I have sort of the overview. So change from land to water and vice versa. And we are interested in long-term changes, and this is important because normally, for example, people who use Earth observation more often, that filtering clouds, for example, from images can be quite difficult. But as we are interested in long-term changes, we don't have to filter all these individual images. So we're going to use some mosaicing to make sure that we get a good yearly image. This is called compositing. So that's what will do also in the workshop. And we have a global focus. So that's also very important. We don't want to see only just a little area and to really fine tune all the parameters for that. But we want this algorithm to work anywhere on Earth. So these are the goals. And the current status of the notebook on openEO is an interactive notebook that implements the algorithm for any area of interest. As you can see in the last slides, we've been using multiple missions in the main product. So it's L4 stands for Landsat, which is a NASA mission, and S2 is Sentinel-2, so that's a satellite mission from the ESA. In this case, we're only using S2. And the current backend provider which we use, which is Vito, supports us with data from the last 2 years. So in the notebook, what I'm going to show you is data for the last 2 years. Of course, if it is a backend that has more data, you can use the same code to use a longer time period. But for now, we are happy with just the 2 years. And what I'm happy to see is that this result that we get at the end of the workshop still really matches the original implementation. So we are going to go to the app that we have made and then check for significant changes for the last 2 years. So let's take a nice area of interest, like you can see here, and you will see that you can really get these surface to water changes and vice versa, also out of the openEO implementation. So far it's been working really well. So that's a sort of pre-phase. And now I'd like to go to the actual coding part. So let me close this part. Yeah, let's see. Do we already have some questions? Yeah, okay. So let's start with logging in. So I see already some questions on that. So let me share my browser and get to the logging in part.
And
so
I will share actually the password. So I have shared the I've shared the logins yesterday with the 20 selected participants. I'll share the password here to actually get going.
Good. So then you will be sending the passwords to the individual participants right now?
No, I will just send it in the chat because without the login, you can't do anything with the password. Right.
Okay. Yes, of course. Very good.
Good.
So let's see. So let's go
I've
to
just sent the password into the chat.
openEO.cloud.
And I'll delete it probably in like 2 or 3 minutes.
Yes. Perfect. So let's see. Yes. So in this case, as you showed earlier, we can go to openEO.cloud. So maybe let's share all the links that I'm using in the chat as well to make it easy. And we will go to Jupyter Lab. So you start at the top, openEO platform. And as you showed in the last presentation, we go to Jupyter Lab. So let's close this. It's a big sign-in button at the beginning. And we'll be going to sign in using openEO platform. And I'll have to see what happens because I'd like to, maybe I have some cookies. No, it's good. Right. So let's log in with openEO. You just used 35 or you're still logged in? Because I know you used 36.
You can use 35, that's fine. Yeah.
Okay.
Should be good.
Let's copy the password. So then you get into this check-in screen. At this check-in screen, you will get some information about, well, who you're logging in as. And there's some options. So there's some data privacy information, some other information, and they ask you to agree. In this case, I choose to agree, except that when the information changes, then I have to ask again. So they will ask me again. Keeps asking me to translate, but I don't want that. I like English perfectly fine. And then we log in into this environment. And as you can see, I already start with some projects, but I will delete. If you're okay with it, Ben, I can just start from scratch.
Sure, go ahead. Like, no worries with these users.
Okay.
Like, yeah, this is actually my account, but go ahead, Jaap.
Okay. Yeah. Okay, that's good. then let's see what happens. But in the beginning, what I've created is
Japp. Can you just start one more time from the openEO platform login with
yeah, sure.
Because we have already questions to log in.
Yeah, I cannot
just use a private browser window and
yeah, I will use a private browser. So I copy the link from the chat. So that's openEO.cloud. And I hope that it opens here. No, it opens in this window. So no, please. So I think you now don't see my new private window, right? So I have to reshare. So let me then share the correct window using Teams.
We saw your Jupyter Lab window. Yeah.
Yes, but I want to show the incognito tab so that I don't have any cookies, and then I can just show again. So let's log in. So let's copy the link from the chat and post it into the browser, openEO platform. So that's where we start. openEO.cloud will get you on this page. We scroll down. We go to clients. And here you see some things. So for example, Benjamin has already showed us the R language platform editor. And in this case, we're using the Jupyter Lab environment where we will be using a Python notebook. So in this use case, we'll be using the Python client library. And we can dynamically edit that in the environment. So then new tab opens, if it's correct, on eolab eodc.eu, but you can just go from here. Now we'll close this window now. There's a big sign in button in the middle. So we just right click on the arrow next to the sign in button. And then you can choose how you will log in. So are you going to use the EODC identity provider or the openEO platform? And of course, this is an openEO platform training. So we use the second one. And hopefully all right, so then we get to a page which is called the EGI check-in. Well, of course, Benjamin already told you something about it, but this is a way to log in via EGI. EGI has managed to fix that for us. And in this case, I also want to use the EGI SSO. So you can see here either you have a list of things you can use here. In this case, there's also a quick button at the bottom, and it's in the middle. So in this case, please choose the EGI SSO button in the middle to log in. So I click it. And here you can paste the username and password that's been given to you by Benjamin. In this case, I used openEO 35. And from my local password manager, I'm copying the password, pasting it in. And you click on login. And here again, some information. I already explained this. So I just click on accept using the middle radio button. Okay, so let's see in the chat. Yeah. So
everyone in the chat who does this right with us is now in the openEO platform lab.
Yeah, let's confirm that everyone is with us. This is a good one. Good to hear, Aisha. The password was missed by someone.
It's in the chat.
It's still in the chat.
It's still in the chat. We didn't delete it.
Good to hear. Good to hear, Pari. Okay, so I see that I'm not sure what the O stands for, but Mr. Abu Libda, he is not in yet.
I'm just checking his user really quick.
Yeah, so I see I'm in here, and then the image looks good. I will, with the next steps, will come after. First, I want to make sure that those who want to be in, are in, and then we can continue with the next step. So for the password, please scroll up for the people in the chat. I see bienvenue. Or how, sorry for if I butcher any pronunciation. But you can see at 13:13, so 1 o'clock 13, Benjamin shared the password for the accounts. Please use the openEO user that was given to you in the email beforehand. So it's openEO, and then I think 1 until something. And there may be some files already in there, but don't worry about it. We will create. We will start from scratch, so everyone can follow. Okay, so indeed, is the password you entered was incorrect. I think Benjamin, you're working on that right now, correct?
I'm working on it, but it will take another minute or two. So just give me one more minute.
Don't worry about it. We will be fine in terms of time.
Yeah, sure. So Abu, please try again.
I see Esther Maina says kindly reshare the ID and password. I hope you found it already, Esther. Can you maybe confirm that you've managed to log in? Thanks, Tom, for resharing. Okay, I see that I think most people are logged in now. Good to hear. So let's go to the next step. Please let me know if I'm moving too fast. Then I will try to redo some steps. So in this case, I'm opening a new tab. And I'm going to GitHub. In this case, I think it's called C-Skill Community. But I will share the link with you, so you don't have to type with me. Good. So here we are. Posting it here. Thanks, Arjen. And so this is the main repository that we are going to use to run the use case today. In this case, what you see a green button, which is called code. And this is a GitHub. So it's a way to save your code online so that other people can look at it too if you have not seen it before. In this case, this is me. I created this thing together with Anna. And what I want you to do is to clone this repository. So we will move this code from here to your environment on the openEO platform. So what you do is you click this green code button, you click HTTPS, and you click copy this link. So again, I will post this one also in the chat, just to be sure that everyone has it. I'll try to go to be as clear as possible, Aranashin. I'm sorry if I did not pronounce it 100% correctly, but it was my best guess.
That was the last name. Padmi is the first name.
Okay, but
it's good enough.
okay.
Thank you.
Thank you. Okay, nice. Good to hear.
One more thing, in my screen, I don't see like what you saw before. I only saw Sci-Fi Lab and R and yeah, only 2 and open source. I didn't get this page.
Please select the openEO platform lab on that page. There is like there's a start button underneath the openEO platform lab. click the start button, you will end up in the same environment as Jaap is in the moment.
So it's going to be openEO NDV times, something like that?
No, like you can just close the lab, and then on the left upper side there is this blue plus sign. Just open a new
plus.
one. Yeah, exactly.
Okay, so new launcher, and then you get the same page as I do. So apparently this page is under this blue button. So I've posted this link right from the GitHub. So the code HTTPS copy, and then we go back to the lab. And then you see here this little button on the right. So you see here, big blue button. Or to the right is this Git clone button. And here you can post the link that I just that we just copied from GitHub, and then we will clone the repository. So it's cloning. And then what you see here is this new folder, which is called use case Aquamonitor. So again, I'll repeat it once. You start here, code, you choose HTTPS, you copy this link, it's also in the chat. Back this little button here, clone, and you can post it in there and it will clone it for you. And then what you see is we have a new folder here.
Alternatively,
yes?
Just go to a terminal.
Ah, yes. Second option, always nice. You can also have a terminal here. Click on a terminal, and you can say git clone. Also type in the link.
Exactly.
Right?
So if your git clone button is grayed out, you can always just open a terminal and type in git clone and then the link that Jaap just posted. Maybe you can post it in the chat.
Yes, let's see, git clone in the terminal.
Yeah.
Well, and in my case, it already exists, but I can also copy this command into the chat. If you would like to know more about Git, I can highly recommend it. But this is, of course, not the Git training, but the openEO training. So I will not go into details, unfortunately. Okay. So if this is all good, you see a repository, or sorry, a folder here, which is called use case Aquamonitor, which is what I've been working on. So if you double click, or in this case, I think if you're good with Linux, you can also use choose directory. I'm just going to do it via the graphical interface for now. So just with clicking on the screen, you can see that I have like an image in there, some little files, a README about how to use it, maybe for later. But now let's go to notebooks. And then there's this Aquamonitor notebook, which is what I want to start with. So if you double click it, it opens automatically on the right, and there will be some a notebook starting here. And here is where we will start to use the notebook. If you have any problems, please put them into the chat. I think Benjamin, you already asked for a Mahmoud to see if he still has problems.
Exactly.
I see a hand from Padmi. Do you still have a question?
Yeah, I do have, because I was able to get this, the link you sent, but once I copied that link, where should I insert it? I don't see it. Can I share my screen?
No, just the blue button on the left top. And then, yeah, we'll just do it for you together.
Yes. So in this case,
the blue button on the top with the plus sign, and then on the lower part, the terminal. Just open the terminal.
I don't see that part.
The terminal, not see?
No.
So you click on this blue button, and then you don't see terminal.
Let me try again.
just to double check.
No, it's different interface I see.
Okay, you can go into the breakout session. Do you know how that works?
So we have a different we have two Teams meetings. Huh? You're invited for both. There is this one, and there's also another one, which is called, let's see, openEO training breakout room. And you're also invited for this. Do you know where it is? And then Benjamin can help you one-on-one.
Yeah,
exactly. Do you have that? You emailed me that link, or how I get the breakup?
I can post in the link in the description also, in the chat here. So
okay,
let's see. Let's see if this. And please, will you assist her?
So anyone who has problems at the moment, please go into that breakout session.
Shall I wait for you, Benjamin?
No, just go ahead with the remaining participants. I will bring the rest of them up to speed.
Okay, good.
And then you will probably repeat it anyways, and then it's fine. Yeah.
Okay, good.
See you in short.
See you shortly. Okay, so please join Benjamin in the second room if you did not get it working already. And for the rest of you, then I will continue. So follow this link in the Teams if you still have some problems, and then we will be up to speed in a few minutes. But for now, I want to open this Aquamonitor notebook. So I'm closing other windows here and just go double click. So from the beginning, use case Aquamonitor, notebooks, Aquamonitor, and there we are. This will open. So what is Jupyter Lab as we are using it? This is basically a notebook where you have either some pages with just text, which I've written to explain what is going on, and there is code cells, and this is just cells which contain code, mostly Python, and you can just execute it and see what happens. And here, so to execute the cell, you can either click on, I think it's a well, there is a way to just run it with clicks, but what I do is I always use either Control and Enter or Shift and Enter. So Control and Enter runs the cell. So in this case, you just click in the cell and click on Control.Enter. And what you will see is it starts running. So in this case, it's going to install some Python packages for you before we get started with a certain version that I used when creating this notebook. So please run this cell using Control Enter, or if you use Shift Enter, it will run it and go automatically to the next cell. So what are we going to do here? Well, in this case, what I already said, this notebook implements Aquamonitor using this openEO using the Python client. And Benjamin already showed that the Python client is a way to generate this openEO code using Python. And then we send that to the openEO backend, so to the server, and they will calculate or do all the calculations for us and send us back the results afterwards. In this training, we'll be looking at Aquamonitor. Maybe it's nice to show it a little bit. So I will open it. And this is also what was in the presentation before. So I'm waiting for it to load. And it's an app online where you can watch changes from land to surface and surface to land over the last few years. And originally, as you can see, this was created in Google Earth Engine. And now we are going to do a similar thing in openEO. So let's close this. I hope that my internet is fast enough. Good. And then we can see all these changes from land to water. So in this case, For example, we can see that there are a lot of water here in Spain. It's changed over the last few years, and you can zoom in. It's quite nice. And we will try to create a map like this in this notebook. So I go back. And so first we use this cell to install a few Python packages that we need. And then we go to the next cell, and that is where we import it. So here we use some Python internals and some other packages that I'm using. So basically, dateutil is for using dates in Python. OpenEO is, of course, important. We are using a few imports from OpenEO. Typing is something that I like to use myself. Path is for navigating the file system. And xarray is how we analyze the data locally. And now here I use GeoViews and HoloViews together with matplotlib for visualization. So here I'm going to import both using Shift-Enter to go to the next cell. So I click on the cell, Shift-Enter, and we go to the next. And I run these three cells, and as if it's correct. And please let me know if this is going well. Otherwise, we might have to install a few more packages on your side. You will be able to run these cells, no problem. So I'm going to go to the chat. Let me know if you were able to install these packages and import it using these import statements. Good there, Aisha. Okay, good. Björn, you have your microphone on, so can you please shut it up? Thank you.
Sorry.
No problem, man. All right, so this is already also shown by Benjamin before. So here we connect to the backend. So, well, I tried two backends, but for this training we use openEO Cloud. So as you can see, I still have the veto URL here. So this is a little mistake. So please connect to the openEO platform URL. So in this case, change this cell instead of backend URL, instead of veto URL, please use openEO platform URL and paste it in this cell. I think the other one will also go fine, but let's see. And then we use the connection to connect and then to authenticate as ourselves. And then I create a directory for the output. And here I select this collection. So it's a Terrascope Sentinel-2 top of canopy collection that we will be working with in this notebook. So I run the cell. And what happens is you get asked if there's not been any login on your notebook to visit a certain site to check if it's really you, and you get this code. So I copy my code. You will get a different one, and you can go to this link. So I sign in. Again, you give openEO a few things, a few rights, for example, to view your email address, some rights to resources. In this case, this looks fine to me, so I say yes. And I log in, it is successful, close my browser. And if we go back, you can see that the authorization was successful. Let's check the chat again. No messages, so I'm just going to slowly continue. And now, as we have seen, in this case, I already knew which collection we were going to use. But if you don't know it, you can always do con.list connections. So this is the connection object, list collections to show connections. So in this case, you can see, I think last time Benjamin also showed there's quite a few collections. You can search for it for Sentinel-2. And here you can also find the one that I'm using. Yes?
Can you repeat, please, because I missed the last steps. I'm in the connect to the backend step.
All right, very good.
Thank you.
Okay, so I will go back. So in this case, there's a connect to the backend. And I have two URLs here. One I called Veto URL and one I called openEO platform URL. And here I'm saying backend URL is equal to openEO platform URL. So I think in the original version, there was this Vito URL here. Maybe because I was working on the Vito URL, but in this case, please copy this one, paste here, connect to openEO platform URL, and then we use connect. You get asked to go to a different website. If you enter this, I already connected, and you get a code here, which is different from mine. Copy the code, go to that website, and log in. So maybe I can still, I think maybe this won't work. It still works. So you get a site like this. Please copy the code in there and submit. There'll be a new screen, which you have to accept, and then you are logged in. If I use this again, it will show that I'm already logged in. All good? I see Abdullah failed to retrieve access token. Did you accept all the options? That's a good answer. It failed. Okay. What? It works now. Okay. Aisha, can you maybe tell me a little bit more about what happened?
Maybe because I changed the Vito URL to the openEO platform URL you mentioned, but now when I revert it back, when I revert it back now it works, but I have to check the site, yes, and which for the first link, yeah. No, something else. Which link should I put the code in at?
The openEO URL, you should put as the backend URL.
This won't work. If I use Vito_URL, I will get the code.
Then it works, or then it doesn't work?
Yeah.
If you use Vito URL, it works for you, or not?
I get the code for Vito.
You get the code. Okay, then use Vito. Don't worry about it. It's also okay.
So I copy the link for Vito?
Sure. If that works for you, please use it for
now. When I put
it doesn't
the
work,
link,
or it does work.
It doesn't work. I just get the code for Vito, but then when I copy the link for Vito in the browser, it doesn't work. There is some.
So try this one. Try the other one. Try openEO platform. Just like what I have. If it's correct, it will still open this site, show you the link and the code. Paste the code in the link and see if you can connect.
I don't get the code if I use open platform URL.
Okay, then please use this button, which is called restart the kernel, and we can try again. So in this case, I can show you. You click restart, and then you have to go from the top. So shift enter, shift enter, shift enter until you are back at the place. And then let me know how it goes. This import takes a little while, but then you should be there in a few. So I'm already now back logged in. Let me know how it goes.
The thing is, nothing happens. Now, okay, I got a message. OIDC token response did not contain refresh token. Authenticated using the refresh token.
That's good. Then you're logged in. So I'm not worried about it.
So where
so if you now execute the next cell, so let's go to this cell and you type shift enter, you get the output. You click this cell and use either control enter or shift enter if you want to go to the next cell or this cell. Do you also get a nice output like this?
It's really not the same, but I got Terrascope S2.
Ah, yes. So in this case, we have a list collections. So that's this line. And this line is commented out. But if you use the second line, so it's like you just delete this, what is this called? This, I think a hash comment.
Yeah, comment.
Then you get the same output as me, right? So in this case, I'm going to use this collection. And then you can get more information about it. So in this case, you can see what kind of collection we are using. So in this case, these are images, satellite images, over the last 2 years over Europe plus other selected areas by Terrascope. And then you can see a little bit about it. For example, who is giving it to us? In this case, it's Vito. You can see some information about the bands, the labels of the bands, what dimensions are in this data cube. As Benjamin talked about earlier, there's a bands dimension. There's a time dimension called T, and there's X and Y. And you can see even that it's every 10 meters, there's a new pixel. So it's a 10 by 10. And here you can see all the details. So there's a lot of bands in there, from blue, green, red, near infrared, the amount of meters. I think if you are familiar with satellite images, this should really be familiar for you. So this is where you can get more information. The next cell is about the processes. So you can list processes here. But in this case, I've commented it out, but I can show it to you. But Benjamin also showed this already in the earlier presentation, where you can check all the things you can do with the data. So all the processes that you can apply to the data. And I will show some examples afterwards. So I'm collapsing this one. So let's start with the first step, which is to load the imagery. So every data cube starts with loading some collection. So in this case, we're going to load the collection that we are viewing right now, this Terrascope S2 TOC. So we start with loading this imagery. And then, of course, I don't want to load everything from the whole world over the last 2 years. I want to load a certain small bounding box. So I've shown it the coordinates. I have called it as a variable. It's called Embales de Barbate. And this is a small area in Spain in which I could see really interesting changes on this app. So I've been just looking at the interesting areas here, and I chose a nice place where I can show off how the algorithm works. So in this case, please just leave it as is, but maybe later if you want to play with it, you can change the coordinates. But for now, leave it as is. And what I do here is I do some things on the, I'm getting the UTM zone, which is for plotting later. And what I'm doing is I'm choosing certain end time, I'm choosing a start time, and then I'm filtering. If we are loading the collections, I'm loading on the collection ID, so I want to get the right collection. I'm filtering on the spatial extent, so where. So I'm loading in this small area that I've defined here with the coordinates. And I am loading in only data from the last 2 years. So as you can see, I'm loading datetime.utc now. So all the data from right now until 2 years past. So from 2 years ago until now, I'm loading in the data, and I'm loading only the few bands, and the bands are called spheres. I think this is, I forgot what it stands for, but it's like a higher frequency band, near infrared, and the green bands. And as you could see before, these bands are B11, B8, and B3. And I'm using rename labels to, instead of having these B names, I'm having them as their own name. So this is one of the processes, add dimension and rename labels, that I'm using. And then out of this comes a data cube. So if you execute this cell, Shift Enter again, you see it has run, but it's really fast. And how does this come? Well, of course, here we are only generating the plan. So we are only creating a set of instruction using Python. And later on, we will send that to the backend, and then it's going to run. And I'm going to show that right now. So in this case, it's just loading the data. Maybe we did a little bit of renaming, but the data is almost the same as what is in the collection. But I just want to make sure that we run it fine. And as Benjamin said, there's two ways to download it. You can do a synchronous download, where you can just download and wait for the data, or it's asynchronous downloading, where we just start a job, and this job will run, and then I'm waiting for the collection to finish. So in this case, I could also start a real long job, which takes days or weeks to run, and I can just log out of my computer and later on come get it back. But in this case, we choose a small area and it should run in a few minutes. So I'm doing this. I'm executing this function, which I created myself. If you're interested, you can check in utils what it looks like. But for now, we are just going to run the cell. And you can see that we create a job, which is called a certain Vito-J and then an ID, which is different for all of you. And it's going to start the job. And for now, it is going to run. And when it's done, it will give us some files back. And then we can, after that, visualize the raw data. So this is going to run for a few minutes. So I would like to check if, yes, thank you, Abdullah, shortwave infrared for SWIR. And let's check some questions. So I see from H-Tron, sorry, cannot see your name, but I see a question. Is it possible that we run for the entire world with the openEO platform? And I think it would be possible, perhaps, but you would have to wait for a long time. So please, if you are trying out the algorithm, don't run for the whole world. But of course, if you've tested it and you want to check if you can scale up to more time or more area, you feel free to experiment with it. But of course, it is not wise to load for the whole world. And I saw, Aisha, you were raising your hand. Where we can specify the area of our interest in the code. Good question. So I did that before here. So I created a variable. In this case, I call it a bounding box, where you select the most west, east, south, and north coordinates in this coordinate reference system. And for example, you can try your own area of interest if you want later on. And for example, you can use, I think it's called geojson.io, which I often use, but there's also utilities that Benjamin showed earlier, where you can just, for example, go to a nice area of France and then draw your own bounding box. But if you want to test out your code, you want to use a small area to make sure that it's fast and not calculating for a long time. And you might be able to, for example, select an area, and then here you get coordinates, and you take you fill them into this format of west, east, south, north. But for now, please take the area that I provided, because I know then we are all looking at the same thing. Okay. Any other questions? Otherwise, I suggest, because it's already almost 2, and I don't want to have you at the screen for 3 hours at the time. So please, let's take a small break also for the other participants to catch up. And then I will see you at, let's see, 2 hours and 5 minutes, so 14:05 to continue. And then in the meantime, our code is going to run. And as you can see, it's almost done. I think it will be done in about a minute. And I see one more question from Padmi. Please ask your question.
Yeah, I'm still at the very beginning stage at the where I'm at the Aquamonitor using openEO page, and now what should I do?
Here.
From the beginning. I lost because I'm coming back from the breakout zone. I mean,
okay.
I missed that step.
Okay, so yeah, for the rest, please take a break if you want. I'll be continuing from where I left off at 2:05, and for you, Padmi, so you can click. So these are different cells. So as you can see, there's a different parts which you can run individually, and it's called in Jupyter Lab. It's called cells, and you can click on them, or you can even use the arrow to navigate. And what you do is.
Oh, you mean I had to click the plus 11 cells hidden? That's how you got it?
Yeah, maybe there's some hidden cells for you, and that you can see this little arrow, and then you can just click on them, and then it unfolds, and then here you can do it back. But in this case, just keep everything open. That's the most easy. And then if it's correct, you see this imports, where you can use on your keyboard, you can use either Control or Shift. Control to stay in the same place, and use Enter to run the cell.
So I just click anywhere and
so you click on the cell and then Control and Enter to run it, or Shift and Enter to run it, but also go to the next cell. And then what you can do is run each step by step from top to bottom, and then you should see the outputs below it. And what we've been doing so far is first, I import some code that I need. So if you're familiar with R, I think that's called packages in R. In Python, it's called modules. And I'm using some modules, for example, for visualization. And very important here is, of course, the openEO module that you see here, which I'm importing. So I'm installing it using pip install. And I'm importing it using this from import statement in Python. So you can run these cells. And then here, this is where some, so let me know when you're on the connect to the backend part.
Yeah, I think I'm there.
Nice.
But not
sure
exactly.
If you see some numbers here, then it means that it has run. Can you confirm that you see on the left like a few numbers?
I don't see any numbers. It says from and import.
So exactly. See imports, and then to the left on my screen, you can see this number 2. Do you see my pointer?
Yes.
Or do I need to? Yes. Do you also see like these? For example, here you see also some symbols down this visualization cell. Okay, then it has run. Otherwise, it looks empty. Okay, so if you're at this connect to the backend step, here you can see. So what we are doing here is what Benjamin also showed in the training this morning, where we connect to the backend. So in this case, this is we connect to a certain backend, and then we connect, we authenticate, and then we create a directory for the outputs.
Okay.
And it may be the case that you get a prompt here with a link and a token. This means that you have to still log in on a different screen. So I showed it in the beginning, but you may get a URL here and a code, and then it says, please go to this URL and fill in the code. So then you have to do it. It's quite self-explanatory. You just click the URL, fill in the code, and then it says, okay, you're logged in. Can you confirm that this works? How are you doing, Aisha? Or not Aisha, sorry, I got the wrong person.
Oh,
sorry, I mean Padmi.
Yes, it's
my bad.
okay. No worries. OCD token, but I think no, I think I will follow up later. You should continue the training. I don't want to hold it up.
Okay. Now, well, we still have 4 more minutes, right? There's still break until 2:05, so don't worry about it. But if you want to just watch, then it's also okay. You can do it at your own time. But there will be a recording if you feel pressured. But we still have some time to answer questions.
I think I didn't get this something wrong. It's better looking the steps, because when I go back and forth, I'm missing certain things.
Okay. Yes. Well, you can feel free to just follow along and maybe also try the exercises when we get there. Okay, then I'll take a 3 minutes break, and then
thank you so
to
much.
save voice, and then I will talk to you all in a few minutes.
Yeah, thank you.
Yes, thanks for the break. Let me start sharing my screen again. So quick overview for everyone who's just come back. So what we've done so far is install and import the right packages, connect to the backend, also authenticate to the backend, check out the collections that are available and even describe this collection. And then after that, we define a certain area, a certain time extent, and a certain number of bands that we're interested in. Load the collection, filter and immediately filter on all these different places and times so that we don't load in the whole world. And we are ready to launch a job and finish the job. And now we're going to explore the data set. So in this case, in this code, we have created an output directory, which is on the left. You can see on your files, see output. This is the directory that we just created. So as you can see, it's created 16 minutes ago. And you can click on it and you can see I called this out there/raw. So here you can see raw. And there's a netcdf file in there, which we just created. So let's check out what's in there. And then for this, we use xarray. So it's a Python package is well known, well used, with which you can open these kind of netcdf files and inspect what's in there and also work on it. But in this case, we're just interested in visualizing it. So I'm opening it using xr.openDataset. If you run the next cell, so it's again Shift Enter or Control Enter, depends on whether you want to go to the next cell. You can see that we have, let's see, a few dimensions. So there's t, x, and y, of course. So these are coordinates. And there's data variables, and these are the bands that we just named. So there's the CRS, which you can for now ignore. And this sphere, near, and green bands. So let's visualize it. And I'm using here OpenStreetMap and the HoloViews and GeoViews package. I know that everyone has their own preferences in terms of plotting data on a map, but I like these packages because they allow you to make nice interactive plots in a notebook. And that is what the next two cells are for. So in this case, we define some of our variables and some of our dimensions that we want to show. And here, making sure that we are using the right datetime format in our plot. And then we create a GeoViews dataset using this line. And in the next line, I'm currently constructing this image. I'm not going into the details of the package, but if you just execute the two cells, if you want to read more on it, you can just click these links for HoloViews and GeoViews later when you view this notebook for yourself. But what it does, it creates this OSM, so OpenStreetMap, and on top of that is the map that we create. And as you can see a satellite image from, let's see, this is the 28th of September. And you can scroll through all the images that we have, and it may take a while to update, but you can already nicely just see different images. Some of them are not as nice as others. So as you can see, this one is clearly some kind of, can we really call it broken, but it's not a good image. As you can see, there are many good images in there which you can clearly see this sort of water edge and some sedimented area. And I think as you go in the beginning, you can see that there's still quite a sort of a mixed area where you have some sediments and some part of it's clearly water. As we go further in time, you can see that this area, sometimes you see clouds, that it gets like less and less water over time, and this is also what we want to see in later plots. So for now, for the next few steps, what the part of the algorithm is smoothen the image. So this is this resample method that was also shown by Benjamin, where we resample the points on a different solution. So as you could see that these bands were in, I think it's 10-meter resolution. And in this case, the the B11 and B8 bands are, B11 is in 20-meter resolution and other bands are in 10-meter resolution, and I want to smoothen them to 30 meters just to make the algorithm run a little bit nicer and a little bit faster. I use a resample spatial method, and then we are going to divide the data into time bands. So as I was saying all the way in the beginning, what we are interested is in long-term changes. So we are not interested in each individual image, but over a year, I want to create a sort of yearly average image. And this is done by dividing all these images into years and then aggregating. So in this case, I'm reducing dimension, or well, aggregating, not reducing, aggregating all the data from a year to a single image. And this is called, I think, I lost the term for a second, but it will get back to me soon. But we create a sort of yearly image. And this is done in these few cells. So here I'm creating using pandas, which is a often used Python package. I'm creating a date range. So let's run the cell and see. So if I create now a new cell, you don't have to do this yourself. You can see that we have a date time index for 3 dates. So from 2020, exactly today, but then 2 years ago until next year, until now. And the next cell shows that we are creating time intervals. So in this case, I'm just creating 2 buckets of time. So let's just run this cell and show you that we have now 2 intervals, one from 2 years ago until a year ago, and one from a year ago until now. And over that time, I'm going to use this data cube that we have, this smooth data cube, and I'm going to apply the aggregate temporal function on it, which is one of the processes that is available by the backend to aggregate over these intervals. And I'm going to use processes quantiles reducer. And in this case, what I'm doing is, so I'm going to choose for every pixel in the image, I'm going to take all the values from all the image of that year, and then I'm going to sort it, and I'm going to take this fraction. So this is the bottom 20% images, and that is going to be for every pixel the value of the output. So for every year, or for all the images in a year, I'm just going to use a certain average pixel. And what comes out of it is that the top amount of pixels are all going to be clouds, because they're the most white, so they're the highest value of the pixels. And the bottom ones may be like strange values because of some events, or perhaps the sensor was not functioning very well at the moment, or there was a lot of shadow from the mountains because the sun was on a low position. There can be many reasons. And then we're going to take the 20% sort of average image on every pixel. And this is also for your question, H1. This is that I am. These are excluded by using this average image, or not really average, but it's not. It's a percentile image. Let's see. So that is what this cell does. And let's see. So in this, I'm not going to go into this cell. I'm thinking maybe let's say leave this for another time. And so what I also want to make sure is that if I'm using a year of data, on some places in the world, there may not be enough images for a certain year. So in this case, I'm creating another data cube, which I'm calling the count data cube. And here I'm using the green band. So I'm using this dot band operator. And I'm selecting the green band. And I'm again doing this temporal aggregation. And in this case, I'm just going to take the sum of all the images that are at a certain, and I'm just going to count for every pixel how many images are covering that pixel. And this, I will use this later as a filter to make sure that I'm not creating this sort of image where there's only two satellite images available, because then, of course, there's a large chance that it may not be a good image. So this is also one of the steps. And now the next step is that we are creating from this time bucketed cube. So that is right here. We are calculating a few indexes. In this case, I'm going to calculate the NDWI, which is a good indicator for whether a certain pixel is water. And the next one is another version of it. And this is by using another operator, which is a sort of apply operation. So in this case, I'm selecting these few bands and I'm calling them green, near infrared, SWIR, and I'm using the dot band operation, using these band names. And then I'm going to do some simple like band math on it. So I'm subtracting the green band by the NUR band, and I'm just following these formula to calculate cubes containing this output. And I'm going to do a little bit of rescaling to make the differences even more, to accentuate it. And in this case, I really like to show also the results here to show what we've been doing so far. And I'm also going to use this, there seems to be a little bug in my notebook. This is kind of strange. Does any one of you also see this this kind of line, or is it just me? I'm missing a cell, it looks like. Oh well, let me try to reload this page. For everyone who is already there, please please don't, but I'm going to try it again. So let's try to reload this page perhaps, or open a new window. All right, so I'm shutting it down, opening a new one, and I hope that I don't have this bug now available. I'm just going to run all the cells until we were where we were. Luckily, it's quite fast. Already running. Apologies for this short break. So we created the date range, we created the intervals. We are counting all the images available for each pixel, doing the band math. And here it seems quite empty to me. All right, now you're following along with me? Do you also have the same
Hi, it's Queen here.
My ID.
Our code is still running, so we need a couple of minutes before it show whether we could run the line or not.
Okay, So it's still running this job in the backend where it says queued and wait and started running. Okay.
Exactly.
Good to know. I didn't know. Yes.
Yeah.
So I think I already see someone who can see it normally. Because here I have just one cell. It's kind of strange. Okay. How to fix it for myself? Because is Benjamin still in this training or no? Is he in a different room? I think he's in a different room.
I think he's in the breakout room.
Yeah, okay. Okay, let's see if I can, because here I have also the debug scripts, so don't look too much at it, but I hope here, yeah, I'm missing this cell and this one. So let's see. I'm going to copy the cell. I hope everyone doesn't have this problem and it's just me, but I'm just missing a cell. It's really strange. Do you also, let me just double check. Otherwise we have a problem, but we are missing a cell.
Somebody already copy pasted in the chat as
well.
well.
Yeah, you
so
missed
they
this.
Have the cell.
What I really don't understand. But
just you. Yeah.
Yeah, it seems to just me again. Okay, weird. Let's forget this ever happened and continue. But so here we're doing the same thing. So we have this MNDWI cube, and then we are going to download it. So what this is indeed, so we created a cube and of a percentile image over 2 years. So from 2 years ago until last year, and from last year until this year. And now we are dividing from those two, that average image. We are going to subtract a few bands, so calculate this index, and then we're going to inspect it. And of course, to inspect something, you have to send this data cube to the backend, and then it's going to queue it for you and start it again.
Just quickly, Jaap, someone told me that you were asking for me.
Yeah. I was missing some kind of cell when I was running here. Do you know how all the other people seem to have this cell, but somehow I was missing it.
Maybe
have you run into that before? Yeah, I don't think I.
Yes. If you mark the cell and you accidentally tap D, then you delete it.
Yeah, I know. That's like a Vim thing, but
exactly.
Well, maybe I did that by accident. Let's see. But anyways, I got some help also from the chat, and now we're back on track. So, but thanks for checking in.
Thanks to chat.
Thanks to chat. Yeah, exactly. It's all good.
All right, I will be in the other meeting if anyone needs help. Right, just don't hesitate to go there. See you there.
Okay, good. So as you can see, it's still running on my end, so that gives also other people time to catch up. And I think it's still running. And I want to show these results. And then I think after that, it might be time to go to an exercise to reproduce this, but then on a different on a different data set. But first, let's give myself a 1 minute break or 2 minutes until it's done running. And also to have you all catch up on the script. There's still any questions, so don't hesitate to ask. Mahmoud, there's a link. I can put another link in the chat if you want to join the other room. Let's see if I have the correct one. Yes. And feel free to ask any other questions. So as a result of this, what should come out is that we have an image. So it will be two images, one for the average image of last year and one from the year before. And then it will show this spectral index, which is a good indicator of whether a certain pixel is water or it's something else. So in this case, we interpret it as land. And let's see if it's a bit correct compared to what we saw before, where we had this just a blue image. I think this was we used here the green band. So what I want to see is that there is some water here and there is some land above and maybe a questionable area where it's not quite sure. So it's finished. It's a good sign. And in this case, what I did do is you can, of course, download the files, but you can also get the URLs where the files are located, because, of course, they're not going straight to my computer. First, they are stored on the backend, and then the backend serves them to me over the internet. So in this case, what you can also do is just show the URLs. In this case, they are at the Vito backend via the openEO platform. And I'm going to open those URLs and then also just get the data from there. So let's see. Again, I'm using GeoViews and HoloViews to plot the data. Here I'm opening them with Xarray again. I'm using these scripts to do a visualization again, using plotting these on the map. And in this case, we are showing the MNDWI, where a high value, so near 1, it's quite sure. There's a high probability that the pixel is water for this year, on average, as a percentile image. So it's and you can also scroll here again. Of course, we just have 2 years in this case. So what we can see is here is quite sure there's water for 2020 until the year after, so in September. And the next image, we can see that sort of the water seems to be retreating. And of course, this is the outcome that we want. We want to see where land changes to water and vice versa. So I want to stop here with the algorithm because we still have 1.5 hours to do the last few steps. And I've also prepared some exercises because now we're just executing my notebook. And I'd like to also for you to try the openEO yourself in a notebook. So what I did is I created a folder which is called exercises. You can see this on the left. And the idea is that in here, I have 2 other notebooks. One is called answers and one is called exercises. So of course, if you are ever confused, you can either ask me or check the answers. But please, for all to keep it honest, just start with the questions or the exercises. And here I have some cells. So again, I'm just installing the prerequisites. And then I have an exercise. And these are based on the things that we did so far. And I would like to look at exercise 1 and 2. Exercise 1, I have listed them here. Connect to the openEO platform backend. Authenticate, just as we did before. And load a small area of interest of the Sentinel-2 collection. use the level 2A product, and that's really take a small area, so 500 by 500 pixels as a maximum. So indeed, and if you want to really get an interesting area, I linked here the Aquamonitor website to make sure that you find an interesting area. So here I've listed some few steps. Go to the platform URL, so this is the URL that we are connecting with. Log in, authenticate, explore the collection, and then take an area of interest and load it as a data cube. So you don't have to execute it right now, just load the collection. And this, of course, Benjamin showed this. We showed this in the previous notebook. And if you want to, and out of this should come a data cube with just the raw data loaded. And of course, in the last notebook, I used a few of my own functions. So as you can see, I created this util package, and the idea is just to find out how to do it yourself. And I've listed here the documentation page. So if you go there, you have this nice page to show how to do it. And if you here, you have a page on finding and loading data. So here it's basically you can find all the information for the exercise here, and also how to work with these batch jobs. And of course, if you're way too lazy, you can also look in the answers, but please try to find out for yourself and load a data cube. And if you want to get an interesting area, there's this Aquamonitor page, which is linked in this description. Where you can, for example, so I think I took a reservoir in this area. And you can check out an interesting area by you can also use the same area from the first notebook, or you can find an area by clicking on this extra button, making sure you select the correct year, so 2020 until 2022. And then you can, if you want to try a different area, if you're, it should load, for example, for Spain. I like to use Spain as an example. You can already see that even in 2 years, it can already detect significant changes in certain areas. So this is where you can get an interesting area from. But feel free to also use the same area that I used in the Aquamonitor example. So I think it would be nice to try to get some of these code running yourself. Feel free to ask questions either in the chat or just by speaking up or raising your hand. And then maybe we can, if you have any questions about the exercises. And then I'm looking for exercise 1. Let's see if that goes well. And if that goes well, then we can also try exercise 2. And after that, I would like to continue with the main workflow. This is Aquamonitor. So let's see, it's this one. Yes, so how openEO works with the constraints is you constrain a bounding box. So it's basically a rectangle around the area. And this rectangle is based on the most westernmost, easternmost, southernmost, and northernmost coordinates. So in this case, this bounding box that I have defined is just a Python dictionary. So you see this open and closing brackets, and then it needs 5 names. It needs the west, east, south, north, and of course the coordinate reference system. In this case, I'm just taking a latitude longitude system, like I'm not sure what the name of it is, but I know the code. and I am these ones. I think so. West is the. And now I'm always confused with these terms, but let's say if I'm using again this geojson.io website, this one as an example.
Yeah.
Yes. So let's say I selected an area here around this area. You will get a it's called a GeoJSON, right? So it's JSON with these coordinates in there, and here you can see. I'm always keeping latitude and longitude confused still, even after a long time of working with it. Apologies, but you can see that there's a minimum and there's a yeah. So this is longitude, right? Latitude.
I guess so.
Yeah. And here you see that there's the bounding boxes. So these points are of course at twice the top left corner, and then it's just this point, this point, this point, and this point, and again this point that defines the entire box. And the only thing openEO wants to know is what is the westernmost coordinate, what is the easternmost coordinate, the northernmost, and the southernmost. So if I would have this, then of course this is the for example, if I use a point here, so I will draw another thing. Let's see if I can. Oh, my scroll mouse is a bit. So let's also use a point. And you can see that this 4.25 here is the westernmost coordinate. So in this case, the result, if you want to filter on this area, you would use a bounding box equals. Yes, and then I would say west is equal to this point. And the same for east is of course the maximum, so that's this one, etc. And north-south is the same. So east.
So the two sets is actually latitude and longitude.
Yeah, exactly.
Oh, okay.
It's just the minimum and maximum latitudes and the minimum and maximum longitudes. And then of course you also have to define which reference system you're in. And this goes into the load collection function as spatial extent. And if you want to know more about this function, so in the exercises I linked to the client documentation. So and here there's you can either do a quick search. So in this case you can go to load collection. So I can also post this into the chat as well, just to make it even easier. You can go to load collection, and here you can see also documentation on the Python client from openEO. And here you can have some more information about it. So let's also post that sublink. And here you can see the arguments. So in this case, you see that you have to have a collection ID. Temporal extent is optional. Spatial extent is optional. You can also define bands and even other properties. And of course, here for loading the collection, if we go back to the main page of the documentation, so let's just go. Finding and loading data we'll also have some examples here. So again, in the documentation, there is on the left is a table of contents. You have like getting started, how to install, and there's also finding and loading data. And here you see also the same commands that we used in the beginning of the notebook, where we say list collections, describe collection, and how to explore what is there. And in this case, they also show you how to filter for spatial and temporal extent.
Yeah, okay. Is this very clear now? Thank you very much.
Nice. Thank you for the question. Feels good that someone is doing the exercise, because of course I can see you. So
Yeah. And I'm doing the exercise.
Nice, thanks. Let me know how it goes. I'm not quite sure, but you have to know that this code, you can also access it from your local computer. So if you want to run this Python code from your local computer, it will download it there. So that would be my first.
I don't have the base. I don't have that much basic to write Python code. Is there any code available you can share on the chat list? Then I can copy it and run into my in the platform, in that platform.
Yes, let me. So I think one way is if you. So for example, you have run until. Let's see where I was. I was until. Well, let me first delete this example code. So now it's clean again, and I go to where I was before. So let's say you have a data cube that you want to download. For example, this one. So let's say I have a data cube in the code. You can say rescaled ndmi.flatgraph. I'll post it in chat as well. So if you're not skilled with Python, but you still want to use this Python code, then what you can do is you use data cube. So in this has some data cube. In this case, I use this as an example. And a flat graph. I'm pasting it in the chat right now. And what you will get is this, instead of the Python code, you get this. Basically, this is the recipe that creates the data cube at the end. So this is like a what is being sent in the end to the server. And if you use this, in the because there's more. So if we go to openEO.cloud, this is where we started the whole exercise. And of course here there's Jupyter Lab where we went now. But if you're more comfortable with something else, then you can also always open this editor. So this is not really part of what we're going to do in this part of the course, but still here you can log in and paste this code that we just created. Let's see if this works. String. Perhaps I need to delete the last part. Let's see if this works. Otherwise, I will have to. I'm never using this, so I'm not really an expert on it. But I know that you can just use this graph also to download some code. Hey, let me check this out for you. New script, sure. Visual model. Paste the JSON from your clipboard. I think I just did that. Let's see if I need something else. Nope. Let me just try a few things because I've never done this, but I know it should be possible. Not dict. Oh, this should be. Let's see. Nope. Okay, so I would have to check. I will ask Benjamin afterwards if he knows a good way to get it from your notebook to your local computer if you're not familiar with Python. So let me get back on that, okay? Because I want to start again with the part of the training. So I will give him a message. Yes, wait a second. So I hope everyone's back. I will answer the question when Benjamin is back. So please, if you can mute yourself, then it's nice and silent again, and then everyone can hear me. Thank you. Good question. So I will put it in my notes to answer it at the end. So where was I? Sent a message to Benjamin, and then I will continue. Okay, so I hope everyone is back so that we can continue with the rest of the notebook. So I just want to do a short recap. And don't worry if you are not finished with the exercises, because you still have the answers, and maybe at the end we will have some time left until 4 to ask questions, because we have gone quite far in the notebook, and there's still a few steps left. So I just want to recap all the way from the beginning, just to make sure that everyone is back on almost the same page, at least in the conceptual level of what we have done so far. So again, import all these packages, and of course the important one is the openEO package that we are using to create this recipe that we send to the server to do all the calculations. Then we connect to the server using also this package, authenticate using EGI provider, and then we're exploring the collections to make sure we get the right one that we want. In this case, I'm interested in this top of canopy Sentinel-2 collection from Terrascope. You can also see all the band information here to make sure that you know what you are working with. We have loaded the data and filtered on a certain area of interest, the time that we're interested in, and also the bands that we are interested in, and renamed it. We checked out this data by downloading it locally and visualizing it using an interactive plot. Then we did small smoothen step. We divided it into these time bands so that we can create a yearly image, because we're interested in long-term changes. So we don't want to see every single image, but we just want to know the trend over a few years. Then we also did a small count, which we will use later to make sure that every year has enough images in it. We created this spectral index and downloaded it. And now we also wanted to plot the result. And what you could see here is that indeed you see the water retreating towards the south. And that was where we were left off. So I want to continue, because now we have 2 different time steps. And perhaps if you have a backend that has more years, you will have even more than 2 images. You want to know the trend. And in this case, the algorithm is quite easy. We are just using a linear regression. So a linear regression gives us the trend over the few years. And there's yet, as far as I know, and maybe it's just new, there is no way yet to do this directly using openEO processes, because there is no linear regression process. So what is really nice about openEO is that you can not only use the processes that they have, but they have also something which is called a UDF, or user-defined function. And in this case, you can use Python code to just your own custom Python code to create a function that is not available yet on the backend. So this is really nice because this covers almost all other use cases that you want. And maybe perhaps in the future they will have a linear regression algorithm, but there will also be another way of there will also always be another question that you may not be exactly in the backend, and then you always have the option of just creating your own function. And in this case, I think currently it's possible to do at least what I know of is R and Python, maybe JavaScript as well. But of course, as I'm using Python, I'm familiar with Python in this use case. I am using Python to create this user-defined function. So if you're interested in what it looks like, I'm not going to go into detail for now, but I just want to show you how it could work. So I've created a folder here called UDFs, and then there is a linear regression.py. And of course, this is all, again, you can also find this in the documentation. So if you would go to not user-defined processes, but user-defined functions, there's a whole page on exactly with all the examples and everything on how to exactly use it if you would like to do it for your own use case. But for now, I'm just going to follow that example. I also followed it here. And what you get is you get a function that gets a certain class, which is an X-array data cube, and you can even give it a context. And in this case here, I just get the data array from it. It's an X-array class again, what we also worked with in the previous examples. And I just use a functionality in there, which is called polyfit. It's all built into X-array to do this linear regression. So this is actually, these two lines are the most important, where I just do the linear regression and I return another X-array data cube, which is just the slope of this linear regression. And this slope, of course, is my measure for the change over time. So how do you do this in code? You load the UDF. So in this case, I just open this Python file, read it in, and then I am using this openEO function, which is called load UDF. And I just load it in, and I apply it on my data cube. And then, of course, this code I'm also sending to the backend. There's also a way to try it out locally to make sure that you can easily debug it. So in this case, I wanted just to have an example here. Definitely, if you are trying this yourself, you first want to always try everything on a small scale. And if you can do it locally, then of course it's much faster than having to send it towards the backend and then go back to wait for 5 minutes and go to your own computer. Oh, there's a little error and then change. So it's nice to have a way to download it to your own computer and really quickly get the bugs out. So that's why I'm doing it locally, but later on I will also show you how to do it. But this is how to do it on the backend. So you just load your own script using wherever the file is. So in this case, it's in use case Aquamonitor /UDS/linear regression. And I'm just using the load UDF, and then I'm applying this string, the string of the Python code, as a reduced temporal UDF to the data cube. Well, you can also try it locally by getting the files local and applying it here. I'm not going through all these steps. This is a bit of data manipulation, but this is also not in the exercises, so don't worry. Please go over it in your own time. For the time's sake of this training, I just want to show you that it's quite easy to try out locally and to debug it. And then just do a very simple plot to just check out that indeed we are getting some results from the user-defined function. So we have two different images. So we have the image from 2021 until 22 and from 20 until 21. And we want to see the change. So we just do a simple linear regression. And then, of course, what we also want to do is mask some areas that are not appealing. So for example, let's say that a year on a certain pixel only has 2 images. Then we are not interested in showing that result in our final result. So that's also what I've written down here. Masks, we create masks to mask the data that we are not interested in for areas that have too few images, or that there are no clear changes. So it was first land and it's now still land, or it was first water and it was still water. And there's also some other rules that we have built in. So for example, we are not interested if this value of this index that we created has changed, but it's still very clearly land, or the areas where it has changed, but it's still very clearly water. And there we do that in this piece of code. And I think, so we have these values for when it's clearly water or clearly land. We want to at least have a certain slope. So what we calculated with the linear regression, this is the rate of change that we are interested in. And these we just used it's more like a manual fine-tuning thing that we did for multiple places in the world. This was a good value that showed us the best results. So in this case, I calculate this slope ratio, what I want per year, the amount of change that I'm interested in, and then I'm creating these minimum and maximum values that always should be land and always should be water. And then I'm applying, creating a mask. So I'm using that. If you can see here, we have this data cube again. I'm selecting the green band, and I just want to make sure that that I'm counting all the images. So in this case, I'm using aggregate temporal over these time intervals. And instead of using this percentile image, I'm now creating a sum image. And this is using these processes that were available in the backend. So maybe I'm going through it a bit quickly, but if we can recall, I'm going all the way back up, is that the backend has a lot of processes available that you can use on the data. And in this case, if we list the processes, there's a process to aggregate temporal. There's also, in this case, if you want to just know how many pixels there are available for a certain or certain images available per pixel, you can see here that they also have implemented a sum process. So if you apply the sum process on a data cube, if you aggregate it over time, you get all the how many images for that pixel are available over that time. So let's go back. So that is a mask. I'm creating a mask for the minimum amount of value for the things that should always be water, should always be land. And then I'm creating also a mask for the minimum value of linear regression. So these are all just using a data cube. You apply a certain mask using these processes. So in that processes, we import from openEO. So in here, you can see also in the Python client, there's all these different processes that you can use to that you can apply to your data cube. So there's this band math that we did earlier. Let's just scroll up a little bit. That we used for the calculation of MDWI, where we can subtract one data cube from another using this. But of course, this can also be written as MDWI data cube equals, I think that would be green dot. And then you could, for example, look into the you can even just check out the processes. I think we listed them here. Why did we list the processes? For example, if you just want to add something, there's a process called add. Dot add, or it's subtract, right? Subtract. Dot divide, and you can divide it by green add. Where, well, anyways, this is just, there are multiple ways to construct these data cubes. And one of the ways is just using these simple Python mathematical operators like here. It's here below. It's getting a bit complicated. So that's why I'm just using this processes library for it.
Just really quick, Jaap.
Yeah.
This is actually what I meant by Pythonic way of defining the processing graph. So these operators have been mapped to the way that Jaap has just showed the other way to describe the processing. So this is the Python advantage over the other clients, that you can actually write Pythonic code and it still works. Whereas in the R client, for instance, you have to define these processes one by one.
Yeah. So there's multiple ways of applying a process to a data cube, and indeed here I'm using the method just on a data cube. So you can use MDWI. This is a data cube object that we created before, and then you can just say reduce dimension. This is the process, and you reduce it by dimension. You reduce it by d dimension, and we want to get the minimum. And here we want to get the maximum, etc. And here we use the process less than or greater than, and so you can just apply these processes on top of each other and create this kind of recipe to get your data cube. So there's a few masks in there. So as I said it before, so a min mask that is where all values are so low that I'm sure that it's always water, or that these MNDWI values are so low that I think it's always land. And then we do a little bit of filtering, and then we apply these masks. So in this case, I wanted to make sure that all the masks were a certain data type. So that's why I'm multiplying here, but it's a bit of a detail. And I'm just multiplying all these masks together. And eventually I mask using this linear regression data cube and using the mask function. So it's also another process with the mask that I created here. So if you execute that, and as you can see, these are quite a few steps. So if you would see the result of this, so the actual recipe that comes out of the Python code is quite, that's why I'm so happy that I can use Python if you're good with Python, because just typing this by hand is a bit of a mess, if you can see the length of the graph. So you can have really difficult processes that you can, instead of having to use all this, let's say JSON, you can also just use a Python code, which is a bit more understandable by just having these nice named methods that really show what you are doing. Everyone knows what the multiplying is, but if you see this big graph, it's a bit hard to read. Well, if we did a linear regression, so to show the change between the different time steps and the masking to filter out results from that we are not interested in, we are ready to download it. So here I'm going to download the results. And later I'm going to show an interactive plot where I am going to well, show the final results that from the algorithm, and to show that indeed there are some changes between 2020 until 2022. Of course, I expect this to run for about 5 minutes. If there's any questions or any people who were not able to complete the exercises that still need a few minutes time or attention, then feel free to, if you're stuck somewhere, to ask a question. And otherwise, we'll silently watch the job tick over, and we'll look at the end result. So for exercise 1, we looked at the just exploring the data and loading a data cube. Is there anyone who managed to complete the exercise? Was it too hard? Was it too easy that you just don't want to comment on it anyway? I'm interested to get some reactions.
Well, it's Queen again here. Yeah, so I'm working on the exercise number 1, but I ran into some problem with the package. I guess it's because it's not installed in the DE or something. But overall, I think the code should work.
You got a problem with the package?
Yeah, like the
Can you
utilises package.
Oh, the utils.
Yeah.
Yes. So the utils is something that I created.
Oh, okay.
So it's not in the official package, but it was just to not be too big in the original notebook, because then I had to explain even more. That's what I left for the exercises. But there's if you go, so let me just quickly go to the answers.
Yeah, I was able to load the extent and the map and so, but I cannot visualize it. So.
Oh, not visualize it. Yes. So I think if we go to exercise number 2.
Yeah.
Here I pasted some code because I didn't want to get into this temporal aggregation part. But here I wanted to make here is the more official way to execute this batch job, because I wrote this notebook about a year ago, and since then there has been quite some developments in the Python client. So if we go again to documentation, I'm not sure where it is again, here. And I go back to the beginning page. If you want to visualize the results, you of course first need to download the data, and then this get files function. I think now they have even something better, which is called let's see, batch jobs. So here you can create a job. I think Benjamin also showed this very quickly. But what is even better is that they have one command that does it all at the same time, and this is this cube.execute batch. So if you have a data cube and you want to do it all at the same time, let's see. Yeah, then this is the one to execute it and one go. It's this execute batch command. So where did I find it again? here. So I'll post it into the chat. Cube.execute batch. Oh, or with the code marks behind it, around it, I mean. And then cube, you have to replace it, of course, with how you named your own cube. And then it will execute it. And then here you can check logs if it failed, but in this case, I don't think it will fail, hopefully. And then you can here below it, so I will just also share this link. You can see also how to get the results. So of course, once a job runs, the results are available at the backend, so via this connection, but you still need to download the results. And here they show you how to do it. And you can also check the answers because they're in the second exercise. I also worked out without using any custom package by me how to download it, and it's like 2 or 3 commands, so it's not a huge effort.
Yeah. So the first exercise is just to connect.
Just load it in
platform, and then you get the cube basically. Yeah.
Yes, and then that is just creating this recipe was exercise 1. And exercise 2 is then I did for you already in the code this time aggregation, but then I wanted to from that aggregation to yourself calculate a different index and then download the results and see if you can visualize it in your own way. Because I'm using this package called GeoViews, but I know that other people love matplotlib or they use another thing. So I would love to see what other people use, because I don't have the best perfect way. I think there's a lot of good ways to visualize the data.
Yeah. Okay. Thank you very much.
Someone else who managed to do the exercises that wants to discuss or ask questions, or maybe as stuck somewhere, it's okay. It's a bit. It's a lot of things to do in 3 hours, so I don't expect everyone to just go right away. And otherwise, since we have a half hour left, and the job I think will be done by now. So let's double check. The linear regression results are finished. So let's open the dataset. So I will continue here. We created this linear regression. So the trend, we applied the masking so that we're just looking at the interesting areas in the result. And what I wanted to show off a bit is a nice plot where you can see the results and also do a bit of so like a clickable plot. So I'm not going to go into detail, but what I'm plotting here again is this linear regression result on a map, just as we did before. And as you can see, a lot of areas are not visible. And that is because they did not contain any significant change, or there were too few images. I think from the last few years, there's a lot of images available. So that filter does not really matter for now. And we filtered some areas that were clearly in the land or clearly in the water. And what we now can see is that there is indeed an area that changed over time, and the change was negative. So it went from clearly from water to land, because if the NDWI is high, it's clearly water, and if it's low, it's land. So if you have a negative trend, it goes from water to land. And here you see a nice a plot that shows the different steps that were used in the analysis. So if I click on an area that decreased, you can see that the value, the normalized index went from 1.2 to about 0.6. So this is nice way to in a notebook present your results.
Jaap, just a quick question which I got earlier. Can you export this image as a PNG or JPEG or something?
Yeah, so I think if you want to have a nice image export, like I created this for sort of an interactive notebook way. I think there is a way to export it, but I don't have it. I don't have like the code ready at the second. I would have to fiddle with it for a few minutes.
Sure, but there is a way to export this.
Yeah, for sure. But I mean, that's why I'm also asking for other ways of visualization, because I think everyone has their own methods to do it.
Yeah, exactly. So you could
and they're
just
all valid.
This. You can
also use matplotlib.
Yeah, matplotlib, and then you're totally fine, right? Yeah.
Because the result is just this X array, and I think that's quite widely used. X array Python data array, and you can visualize it any way you want. So if you're in the geospatial tools, you should be familiar with Python geospatial. But of course,
actually, good comment.
Same. Yeah,
good comment from Huyen Tran or ArcGIS. Yes, of course. You could just download the data and just visualize it in ArcGIS or any other GIS library.
Yes, because what you get is either GeoTIFF, NetCDF, and you should be able to visualize it in that way as well. But for a notebook on openEO platform, I like to explore a bit the packages that were made for that. So that's why I googled for a nice notebook visualization package, and then I found this GeoViews, and I really like it. This interactive plot, I think it's quite fancy. All right. So it was a bit of a race, but on the other hand, I hoped that everyone got a bit out of it. I think as I didn't get too much reactions from the exercises, I will leave the rest up to the participants to maybe check it out at home. The answer keys are all correct. I checked that they run. So yes, I think it's maybe a good time to stop here and maybe go to the end of the day.
One more comment from my side. We will leave so the users that you have received yesterday, we will leave these open for you for the next couple of days, so you can still keep using them. We will change them probably beginning of next week, so you won't be able to use them anymore from next week on, Monday or Tuesday. And what we will do, what we advise you to do is anyways to sign up for openEO platform and use the 30-day trial as discussed this morning. You can find all information surrounding the plans here, or surrounding the available service offering. And we would like to welcome you on the platform, and obviously in the forum and any other way. You can also just answer to my email that I've sent to you. And then I will be able to provide you with assistance if you have issues in joining the platform or anything. Yeah, that's it from my side. Thank you, Jaap. And
no problem.
Shiyi, I think you can go ahead and close the meeting, huh?
Yes. So thank you so much, Benjamin, and thank you so much, Jaap. It was a really wonderful presentation. And of course, thank you to all our participants for joining us today. I hope you have enjoyed the training and learned many useful things to apply in your field of work. And of course, please feel free to visit the openEO website regularly. You will find a lot of information and resources about EO data for climate analysis. And just 3 points from me before we go. Firstly, the presentation slides and video recording will be made available in the coming days. You will be notified via email. And secondly, the certificate of participation will only be awarded to those pre-selected participants who attended the hands-on training. And last but not least, we still have one more training under our Space for Climate Action training series. The training will be organized by NASA on the 4th of October on the topic atmospheric CO2 and CH4 budgets to support the global stocktake. And I will put the information in the chat after this, so please feel free to visit our website for details. So once again, thank you so much to all of you for coming today. And of course, a big thank you to all our trainers from EODC and C-Scale. So thank you, and we hope to see you again at one of our future events. Goodbye.
Bye-bye.
Bye.
Bye, everyone.